Okay, so let's go ahead and go over the warm-up. So on here, the best and easiest way I can tell you is you are going to need to write an equation. And you know it's not exponential because there's no exponent of x or a variable. It's not quadratic because there's not an exponent of 2. So these little numbers right here are called subscripts. Those, when you create a table, are going to be your x's. So you're going to write all of those numbers on the x side. 1, 2, 3, 4, and 5. Then the other numbers, 47, 33, 19, 5, and -9 are going to be your y's. So you're going to write them there, 33, 19, 5, and -9. Well, anytime you see a table, you should start thinking list and spreadsheets. So this is what you guys are going to do on your calculators. This is going to be your A column, your B column. You're going to write down what your M equals and what your B equals. And when you get it, your M is going to go here, your B is going to go here. Now here, on a word problem, goes straight to the question. It's asking you for domain, which is your X, and it moves left to right. So I'm going to go ahead and focus on my X. My left point goes down to -2. My right point goes down to 5. So it also says to find 2 correct answers. Start is starting to do more of this, so make sure that you're paying attention to that. So on my first one, it is not correct because my points are not 1 and 8. Second one is correct. It is not all real numbers because the only time it's all real numbers is when there are 2 arrows. So no 2 arrows. Then the second one is going to be asking for your range, which is going to be your Y, and it moves bottom to top. So your Y is your bottom number, which is 1, your top number, which is 8. Well, first one's good. Second one is not 2, not 5, and it's not all real numbers because there are 2 points. Range is not always all real numbers when there's 2 arrows, so just we're going to write that there's 2 points, okay? On the back, it's asking for domain, which is your X, and it moves left to right. The number it gives you is is 6. So you should be going to your answers and seeing if it goes to 6. This one's good. This one's good. This one is not good because it goes to -4. And this one is not good because it goes to 3. So B and D are not correct. Well, when it's less than, because it's going left to right, that means it should go to the left, which is your negative. So this is my negative, this is my positive. This is my negative, this is my positive. A is pointing to the negative, C is pointing to your positive. So C is not correct because it's greater than, or another way to prove and disprove is points to the positive. So that's why A is going to be my answer. And the last one, write in the simplest form. Now, another way to write this is going to be -11 times n to the -4. So the reason I did this is so you can see that they're separate, okay? I need to get rid of my negative exponent, which is over 1, okay? In order to do that, you have to move things around. So you have -11 times 1 over n to the 4th. Well, we don't write 1 in math because when you multiply fractions, you just, I guess, let me show you more of a visual. You multiply across. So then you have -11 over n to the 4th. Can you just put it on the bottom? Absolutely. It's just more to give you a visual. Now for the notes. It says a laboratory experiment doubles each hour. Now, whenever it doubles, triples, quadruples, stuff like that, that is a hint that it is going to be exponential, okay? Meaning it's going to have an exponent of x. Now, your exponential function is y equal a parenthesis b exponent of x. A tells you the y-intercept or the initial. Your b tells you 2 things, if it's growth or decay. And again, if it's growth, B is greater than 1. If it's decay, it's bigger than 0, but less than 1. Okay? So if it doubles, my first arrow is going to start at 2. And then I'm going to times 2, which is 4. Then I'm going to times 2, 8. And then times 2, which is 16. Well, I need to find what it's going to be at when x is 0, because that would be my y-intercept. Well, you can do one of two things. You can work backwards. The inverse of multiplication is division. So you can do 2 divided by 2, which is 1. Or you can think, oh, 1 times 2 is 2. Whatever the case is, it doesn't matter. Okay, however your brain understands it. So then I'm going to come here, y equals a parenthesis b exponent x. Your a is going to be your y-intercept. Your y-intercept is when x is 0. And when my x is 0, my a is 1. So my a is going to be 1. My b is going to be what my change is, which is 2. So my b is going to be 2. Now I'm going to rewrite it. Y equals a parenthesis 2 x. Because again, this is my b and this is my a. Now, in star, they're not going to put the 1 because 1 is always invisible. So you're going to see it like this. It's all the same thing. Just make sure that you're making a note that it's the same thing. Here, how did we know that the constant multiplier, it meant it doubled. That's the word that we highlighted. And then we're going to graph. We're going to do a very rough sketch. Okay, so this is my x. This is my y. My y-intercept is 1. So that is 1. So this is my y-intercept. We said it's growing, so all I'm going to do is just show you that it's growing. So if I were to draw a car and I were to push it, it's going up. So that means it's growth. Also, my b is 2, and 2 is greater than 1, so that means growth as well. Now here, this is literally the equation. Oh, sorry, this is going to be page 587. And the previous page was 581. My apologies. So here, this is going to be the same exact thing that we just did. So my A is 1. My B is 2. So I'm going to complete the table. My equation is 2x. So what I'm going to do is everywhere I see an x, I'm going to put the -4. So I have 2 to the -4. Okay. And again, I don't like negative exponents, so like my warm-up, I'm going to flip it. 1 over 2 to the 4th, which is not 4 times 2. It is 1, 2, 3, 4. It is written out 4 times, which is 1 to the 16th. So 2 to the x, 2 to the -3. So everywhere you see an x, you're going to put -3. So you have 1 over 2 to the 3rd, which is 1 over 8. And go ahead and fill out the next 2. Now here, horizontal asymptote. So I want you to draw a dashed line right here. And I want you to put y equals 0. So what it is, it's the line that looks like it's going to touch, but it never ever does. So it gets closer and closer, but never touches, never intersects. It never touches. So like kind of how I remembered it. It's like your nagging sibling whenever they have their finger in front of your eyeball and they're like, I'm not touching you, right? So it's like that. So even though these graphs look like they're touching that dashed line, they're actually not, okay? Now, for the sake of Algebra 1, horizontal asymptote is going to be the only thing we ever talk about, and it's always going to be 0, okay? It's never, ever going to be anything else. So let's take a quick second to talk about my domain. My domain is going to be all real numbers because I have 1 arrow and 2 arrows. Yes, this is multiple graphs, but the whole point is they all have 2 arrows, okay? So because there are 2 arrows, it goes on forever both directions. Your range is going to go hand in hand with your asymptote. So you're going to bring up your y, you're going to bring up your 0. Now your graph, right? several different ways. The graph is above the asymptote line. So it's above the asymptote line, so it would be greater. Another way is this arrow is going up, so it would be greater. It just depends on how you see it, but it's above, so it would be greater. If it was underneath, it would be less, okay?